Okay. So today, so it's a very interesting lecture, okay? And then later on, if you don't have a copy and pencil, I shall give you time to take your pencil or pen and copy, and then we have to write it down, okay? So for the first 10 minutes only, you can simply walk with copy and pencil later on, not now. So let us start our class. So yesterday's class, we finished it over here. So yesterday, what we discussed was that when a potential difference of 10,000 volt to 15,000 volt was applied between these two electrodes, that is the electrode connected to the positive terminal known as anode, and the electrode connected to the negative terminal known as the cathode of the secondary coil of the induction coil, then at a pressure of 0.01 mm of Hg. That means when there were very few number of gas molecules, at that scenario, we find all the glow, that is negative glow, and the cathode glow disappeared. The Faraday dark space also disappeared, and then there was only one dark space that was known as Crookes dark space that filled the whole tube. Okay, we discussed up to there yesterday. And then as you can see here, we find the fluorescence on the wall of the screen, right? So as you find the fluorescence on the wall of the screen, and then here so as you find the fluorescence on the wall of the screen, we just predicted, or the scientists at the time predicted, that there has to be something that is coming out of this cathode plate. And then they studied more on that one. Okay. Now, in order to study this something, that is something hidden that is coming out from this cathode plate and entering into the anode plate, now they took different sort of discharge tube. This is known as Maltese cross, okay? And then the next one was, this is fluorescent screen, okay? So with the help of this one and paddle wheel, what they studied is, what is that is coming out from this cathode and then making the wall of the discharge tube glow, okay? For that one, what they did was, finally this. Now what you can find out here is, so here this glow and this glow here, and this glow is because of the ray, okay? So an invisible ray is coming from the cathode plate and it's entering to the anode plate in this discharge tube. Similarly, this can be shown here of invisible rays coming and then providing fluorescence on the wall of the screen. Okay, so they found out that there is an invisible ray, and this invisible ray, as it is coming from the cathode and ending at anode, so they named it as cathode ray. Okay, and then they started studying the properties of that cathode ray. And then in order to study the properties of the cathode ray, they took this discharge tube. Anyways, here is a Maltese cross. Okay, this cross, as you can see it over here, here you have got a cross, and this cross is known as Maltese cross. Then what can you see here is a shadow of this Maltese cross. So here, whenever this Maltese cross is placed in between the cathode ray, or between the cathode plate and the opposite side of the cathode plate, or this wall, they found that the shadow of this Maltese cross is here. So what they predicted is that, okay, so there is the invisible ray that is known as cathode ray. So if they are providing the shadow, then obviously it is the ray, okay? And that ray is an invisible ray known as cathode ray, because it is traveling from the cathode plate to the anode plate, as you can see over here. But the question was, now, is that ray a wave or a particle? Okay, so that's the real question now. Now they found out that it's a ray because it is casting the shadow, and here on this multi-cross discharge tube, and then here also it's casting the shadow on the wall. Okay, so if it is casting the shadow, then it has to be a ray. They found it out that it's an invisible ray inside this discharge tube. That ray is cathode ray, originating from cathode to anode. Now they were confused, and there were two groups. Okay, one of the group were English scientists, that is scientists who were born in Britain, right? And then they said that it has to be the particle. The ray has to be the particle. But the other scientist or other group was from German, okay, Germany, right? And then they said that no, it has to be a wave. So by simply looking at this, we can't predict whether it's a wave or it's a particle, okay? And then they studied the properties of this cathode ray. And then here what they found was that when they studied the property of the cathode ray, now see here, so from this, they were confused. They were just saying that it's a ray. They know that it's an invisible ray, but whether it is the particle or the ray are made up of particles, or whether the ray is a wave, they were unable to identify. And as it cast shadow, they were somehow tilted that the invisible ray they are coming are waves. Okay, but further as they go on studying the property, then what they found was this property. Okay, now let us see here. Where did it last? Is it here? Okay. Okay, now let us see here. Okay, let us go on. Just go on observing this one. Okay. Okay, I think it's over here. Now let us see here. Now they further go on studying. Okay. Oh my God, where did I lose that one? Okay. Let me see if it is here. Yes. So now up to now, I think you have you are getting my point, right? So they found that there is an invisible ray, but whether it's a wave or a particle, they were still confused. And one group of the scientists, those who were from Germany, said that it's a wave, and the other group of scientists, those who were from the Britain, said that they are particles. Okay, and then they further studied. Now J.J. Thomson further studied this one, because ultimately electron was discovered by J.J. Thomson. Okay, so that invisible ray, how can we say that it's an electron or it's a particle? Now J.J. Thomson still went on exploring the property, and then what it found was that now this is the ray. Okay, this is the cathode ray coming from cathode plate to the anode. Okay, now okay, wait, okay. Oh my God, I missed that. Okay, now, oh, let us see here. I think it's here. Is it here? Okay, it's here. Okay, now see here. So they thought that, or they found out that this is a ray, and this is cathode, and this is anode. So the ray is coming from cathode to anode. So it is known as cathode ray. And then from this study, they were able to tell that electron is a particle. Okay, so let us see here. Okay, now see here. So I think you are seeing it here, right? So this is the ray, and when this ray is brought under the influence of magnetic field, then the ray is deflecting downward. See here, the ray is deflecting downward. Okay, so as the ray is deflecting downward, then they thought that, or they found that it is a charged particle. Okay, so the first experiment, from that Malthus cross, they found that it might be a wave. They're confused. But from the next experiment, where they found that the electron beam is deflecting, they tried to suggest that it's a particle, and they were much more confident by this observation. Okay, so let us see what is this observation. So see here, what you can see here is, okay, let us see here. After this one, go on looking at it. So see here, it's being deflected. So if it is being deflected, then this is the stream of particles, and the seer. Now what you can see here is when the paddle wheel is placed nearer to the cathode plate, then what happens, this paddle wheel, while we just on it here, while you apply the potential difference, then the paddle wheel, this is not a paddle wheel, it will move away from the cathode. So if it moves away from the cathode, then this ray has got the energy. Yes or no? It has got the energy. That's why it is able to move this paddle wheel. So if it has got the energy, then obviously it will have the momentum. So if it has the momentum, then the momentum is shown by the particle nature. Okay. So finally, they were able to prove that this ray that was coming from here, is the invisible ray, and it is stream of negatively charged particles, and these negatively charged particles is known as electron. Okay. So finally, we come on to the conclusion, or we came on to the discovery of J.J. Thomson, how he discovered electron. Okay. So he took this discharge tube, and then what he did was that he studied the behavior of this cathode ray. What he found was that this cathode ray will get deflected in electric field, will get deflected in the magnetic field, as well as this ray that is coming from the cathode, right? If it strikes the paddle wheel, it will move paddle wheel to a certain distance. So if it moves to a certain distance, these invisible ray particles has got energy, and this energy is related to momentum. As it has got momentum, this invisible ray is made up of particle, and as this particle deflects in the positively charged plate, right, while the electric field is applied, he came to the conclusion that is made up of particles, and these particles are negatively charged. So negatively charged particles are known as electron. Okay, this was how the electron was discovered, by studying the cathode ray tube. So if we had to explain, okay, so let us explain it. Okay, how do the J.J. Thomson, or how did J.J. Thomson discover the electron? Okay, so what was here? Now here, if we make a certain hole here on the anode, then a glow will be seen here, because invisible ray particles are coming and then striking here on the wall. Okay, and then if we bring this particle, this ray under the influence of magnetic field, here we are applying the magnetic field, then it is deflecting downward. The same ray, if we bring it under the influence of the charged plates, that is the upper plate being positive and the lower plate being negative, then there is a stream of or these invisible ray particles moves towards the positively charged plate. So if it is moving towards the positively charged plate, then this stream of particles has to be negatively charged, right? Because negative charge will be attracted by positively charged plate. So this was how J.J. Thomson discovered that cathode ray is made up of elementary charged particles known as electron. Okay, this is how we found out that this invisible ray that is originating from cathode to anode, known as cathode ray, is nothing but it is the stream of negatively charged particles, and one of the negatively charged particles is known as electron. So is the stream of electrons, or it is the collection of the number of electrons that is originating from cathode plate and striking the anode plate when the pressure here is around 0.01 mm of Hg. That means only lesser number of molecules are present, and an electric field of around 10,000 to 15,000 volt was applied. So finally we understood how J.J. Thomson discovered electron. Okay, now after that, now we'll be studying about the different properties of this electron. So up to now our lecture was focused on discovering electron, And by looking at the variation of discharge phenomena on the variation of pressure, finally we found out the cathode ray. And on further studying the cathode ray, we found out that cathode ray is a collection of particles, and these particles are negative in charge, known as electrons. Okay, so up to now the lecture was focused on discovering this electron. Now from this lecture onward, in upcoming lecture and today only, we'll be discussing how does the electron behave in electric field. So we are trying to understand this phenomena. Okay, so in today's lecture we'll be understanding this phenomena. How does the electron behave while it is placed in an electric field? And in tomorrow's lecture we'll be discussing how does it behave when the electron beam or when the electron is placed in magnetic field. Then finally we'll be placing electric field and magnetic field simultaneously, and we'll find out the behavior of an electron when the electron is placed inside the electric field and the magnetic field at the same time, that is simultaneously. Okay, and then after that we'll be discovering the quantization of charge, that is Q equals to plus minus Ne. So up to now our lecture was focused on discovering the electron. We discovered it with the help of this discharge phenomena. Now after that we'll take that electron and we'll put into the electric field. Today we'll be doing that lecture. Then tomorrow we'll be putting that electron in magnetic field, and then we'll be putting that electron in both electric and magnetic field. And then as the last section of this chapter, we'll be finding out the quantization of charge. Okay, now for today's so today we are going to study the motion of, so here what we're going to discuss is this one. I've already sent this to you. I think we won't be able to finish the whole worksheet. Okay, but here what we are going to discuss here is summarized here. Okay, this can be note for exam preparation also. So we are going to discover the behavior of electron in an electric field. We have already discovered electron. Okay, now that electron will be placing in an electric field. So for that one, how will we study that one? Okay, how will we study the behavior of motion of electron in an electric field? So I have just categorized it. First and foremost, we will draw the figure of the experimental setup, because we are going to study it, right? So as we are going to study it, we'll draw the experimental setup. Okay, and then after that we'll find the horizontal displacement and the vertical displacement of the electron. Then we'll find the deflection theta of the electron using tan theta. Then finally we'll use the relation electrostatic force E equals to ma, and then find out the displacement, the velocity, and the acceleration. Okay, or we'll find out the behavior of the motion of electron in an electric field. Now for doing this one, I have given you the worksheet. You once go through it right before coming in upcoming lecture, because I think today we won't be finishing all of this one. I think we'll be only doing the experimental setup up to here. Maybe we'll be here, we can reach up to here, or if we can get or if we have enough time, then maybe we can come up to here. Okay, so let us start this one. I think you have gone through this one. So motion of electron in an electric field. Okay, so what does it mean is that, so see here is an electron, and then here are two horizontal plates. This one is the upper plate, and this one is the downward plate. And then this upper plate is positively charged and the downward plate is negatively charged. Now as these are two different plates, then the electric field will be set up here. Okay, the electric field exist over here, as you have already studied in capacitor in class 11. Now while I take this electron, okay, while I fire this electron into this electric field, then what sort of motion or what sort of behavior does this electron show? Okay, let us see here. Let me now see here. What happens here? The electron is moving towards the positively charged plate. Okay, so while an electron is taken or is introduced in the electric field between two oppositely charged plates by applying certain voltage, and there is certain distance. Okay, see here, the distance between positive charge plate and negative charge plate, we have supposed it to be small d, and we have applied a voltage here such that it will be positively charged and this one will be negatively charged, and we have applied the voltage V. At that scenario, what's happening? The electron is being deflected towards the positively charged plate. So just like that we explain it here, right? So what did you explain? We explain it here. See here what we explained was that, now see here, electron beam is coming, or electron is coming, and when it is introduced in the electric field, this one is positively charged and this one is negatively charged, then the electron will be deflected towards the positively charged. Okay, so this is what we see over here. It is being deflected. Now let me make the electric field strength smaller so that we can study much more nice the trajectory of this electron, okay, or the path followed by this electron in this electric field. So let me decrease the electric field strength and let me fire it now. Okay, a little only here. Okay, let me fire now, and then let me make the velocity. What is the velocity? Okay. So, oh my God, I did not get the velocity here. So if I stop sharing it, then again, electric field strength. So let me make it lesser. Okay, just wait. Okay, and then let me shoot. Oh, now see here. So this is the electron, right? And as the electron enters this electric field between these two charge plates separated by a certain distance d, then you can see the trajectory of the electron in this position. That is, it is moving upward, or it is being attracted towards the positively charged plate. So see here, this is the positively charged plate. So this electron being negatively charged plate, this electron being negatively charged particle, while it is being introduced in this electric field set up by two oppositely charged plates separated by a distance d, then we see the electron moving towards the positively charged plate. Okay, so what we'll be discussing here is what will be the horizontal displacement of this electron, what will be the vertical displacement of the electron, by how much this electron gets deflected. Okay, all these sort of phenomena we'll be doing it, and we'll prove that this is parabolic in nature, and then we'll see the strength of mathematics today. We'll just derive an expression mathematically, and that mathematical expression shows that this electron is in fact moving in a parabolic path, and it's moving towards the positively charged plate. Okay, so for this one, now I request everyone to be there with pencil and copy if you are not there. Okay, let me give you 1 or 2 minutes, and be ready with pen and pencil and copy. What's happening? Read on the mode. Oh my God, what happened again? Okay, so if it is on the okay, so now talk to me. Are you there with pencil, everyone? Pencil and copy. Now we have to start writing. Okay, now let's start writing. Okay, thank you. But it's not providing me. Okay. So let me once click it over here. Okay, if it comes or not. And please see if you can see it or not. Okay, here. What you're seeing on the screen, one of you please tell me. Okay, wait. I'm checking the online board. One of you please tell me what you're seeing on the screen. Please unmute yourself and then tell me. Are you listening to me or not? What I'm seeing on the screen? Do you see the pencil over here? Please, one of you, please cooperate with me.
Yes, so we can see the pencils.
Yeah, I'm listening. Okay, yeah. So you can see black pen and all these one, right? So we are trying to draw it. Okay. So here we are trying to draw. So in this question, so here, this is the question that we are going to discuss, okay? Draw the experimental setup is given here, and you have to do it at your home, okay? So here, now there will be two plates, okay? There will be two plates. One is, oh my God, two horizontal plates, okay? So give me time. Everyone start drawing two horizontal plates. Separated by a certain distance vertical. Okay, two horizontal plates are kept here horizontally. Okay, this is one of the plate. Okay, upper plate, and this is the downward plate. Okay, and what we are applying is we are applying a voltage. So you draw here nicely. Okay, I can draw with the help of mouse nicely. You draw nicely, or just go on saying. So we are applying the voltage such that this upper plate we are connecting it to the positively charged, because this is the longer terminal. That means it has got higher potential. Higher potential means positive. Okay, so here is the upper plate is connected with positively charged. Okay, or the upper plate is positively charged. So this one is positively charged, and you have to make the positive of equal size. Okay, not this irregular. Okay, here I am finding problem. And similarly, this negative terminal is connected to the lower plate such that here we find the lower plate being negatively charged. Okay, so see here, now if there are positive and negative charge, then S can be visible here. So see here are positive, the upper plate is positively charged and the lower plate is negatively charged, and they are separated by a certain distance. Okay, so let us separate this one by a certain distance. Here also there is the distance between these two charge plates. Okay, and it is suppose the distance between these two charge plate is small d. Okay, so this one is d. Okay, small d. Okay, and this is the separation between these two charge plates, and it is small d. And then see here the separation between these two charges is small d, and here the upper plate is positively charged and lower plate is negatively charged. So here an electric field will be set up, and then let us suppose that the electric field setup here is E, and the voltage here is V. So this is the voltage here, capital V. Okay, the voltage is V. The distance between these two plates is D. Are you seeing it? Please tell me, one of you. Are you seeing on the screen what I'm doing here?
Yes, sir.
Okay. So the distance between these two plates is D, and the voltage V we have applied. And then electric field will be set up. Okay. Electric field will be set up from positively charged plate and moves towards a negatively charged plate in this way. So similarly here, the electric field will be set up. Here, the electric field will be set up. Okay. So what you do is just below the positive sign, you place negative sign. Okay. And then you can draw the electric field in this way. So here is the electric field setup, and let us suppose the electric field setup here is capital E. Okay, so this capital E is the electric field setup between these two charge plate, and the upper plate of this charge plate is provided with the voltage V, and the separation between these is small d. So in this condition, an electric field will be set up. Okay, and the electric field will be set up. This electric field is E, and E equals to voltage V divided by D. So this is the electric field that you will see. Okay, so an electric field is set up between these two charge plates, and it is equal to V by D. Electric field E equals to V by D. Are you writing in a copy or not? Have you drawn it? Because I require it here. Okay, the next time, I think the next lecture is also required here. After that, you have to print it out, okay, and draw it over here and submit this as the assignment. Okay, are you getting or not? So we are going to discuss this one. We are drawing the experimental setup here. So the experimental setup is in this way. Here, there is upper plate and lower plate. Two metallic plates are here, and we applied the potential V, such that the upper plate is positively charged and the lower plate is negatively charged. Okay, electric field setup is E, the distance between these two is D, and V is the voltage. Then we'll obtain an electric field E equals to V by D. Okay, so after this one, now what we're trying to do is this one's here. After this one, what we do is that we fire the electron here. As we fire the electrons, now let me make the electric field strength smaller, okay? So as to get the nice projectile motion. So as to get the nice trajectory, okay? Now, let me shoot it. So if I shoot it, then what happens? The electron is moving towards the upward plate, okay? So what we are going to discuss here is the same thing. Now, let me erase this one, okay? The electric field. And then make it clean over here. So I'm erasing this one. So I think you visualize the electric field is set up here, and the electric field equals to B upon D. Now what I'm doing is that I'm bringing an electron, okay? I'm bringing an electron. So here, this is an electron, and I'm bringing it nearer, okay, here. So up to now, it travels in a straight path. Why does the electron travels in a straight path? As you can see here, if you shoot it, then here up to here, before it enters the electric field, it comes in a straight path because no any electric force is there so as to deflect this electron in the upward direction, okay? Similarly here, if you see here, up to here, there is no any electric field, so that it comes straight up to here without any deflection. Then after that, as you can see here, what happens? It is deflected towards the positively charged plate. Yes or no? Here, what we find is, so this one was proton. Now, let me, shoot it, okay? So what you find? So this one was proton, positively charged, okay? So if it was positively charged, then it would be attracted towards the negatively charged plate, right? So this is the trajectory for positively charged particle, that is proton, okay? And this is the trajectory for negatively charged particle, that is electron, okay? So the electron is being deflected here. We are saying the behavior of electron in electric field. So here what happens? This electron will be deflected in upward direction, okay? So now let us see how far we will be able to draw it nicely or not, okay? So from here, what happens is that it is being deflected. So see, the electron is being deflected, okay? Now what you are asked to find out here, so this is the experimental setup. Then as you can see it here, here was an electron. As I shoot it, then the electron is deflected in upward direction. The same we have drawn here, the electron is being deflected in upward direction. Now what happens is there, after, now see here, again here is no any force, because here was the force, and that force was because of electrical or electric field, right? And what was the value of that force? Let's try to, let's try to understand, okay, what was the value of that force? Okay, the value of that force was F equals to QE, okay? Or if here we place an electron, then we know that Q equals to, right? Here we have placed electron, so Q equals to small e. So finally, the force on that electron was EE, right? Capital EE. So I think you remembered our class, right? So we're just making a funny sort of, right? While we're showing a funny sort of what you can say in order to mnemonics, right? We're making a funny sort of mnemonics, and then I ask you to turn to your friend and then just do E, right? And that will be electrical force. I think you remember that class. So here F equals to E. So here, this electron, because of this electric field set up in between these two charge plates as given by V by D, okay, it will experience a force, and that force is EE, where E is the charge of the electron, because here is the electron, okay? And as it comes under the influence of electric field, it will be deflected in upward direction. So it's being deflected in upward direction, okay? Now, as soon as it comes here, now here, why is it being deflected in the upward direction? Because it is being pulled by this force, the force that is because of this electric field setup, that is electrostatic force, okay? And that electrostatic force is E. So this electron is being pulled by this force, F equals to E. That's why it's being deflected towards the upper plate. But as soon as it comes here, then it has no an influence, okay? Now there's no influence of force over here. So what happens here is it moves tangentially. I think you have studied in mechanics, right? If we swivel, or if we move something, in a circular, or if we rotate something and let it leave, then it goes in a tangential way. Yes or no? So from here, the electron is moving in a tangential way. So this is the velocity of the electron. It's moving in a tangential way. Now, up to here, I think you are getting it, right? Is there any question? You can ask me if there is any question. Is there any question? So we have finished drawing this one. If there is any question, you can ask me. If you don't have any question, then let us continue. So here in this worksheet, I have sent it to you. Everything, just you need to fill it up. Okay. So the question is, as it has been mentioned in the worksheet, as the electron enters the electric field, it starts deflecting towards the positively charged plate in a parabolic trajectory due to the electrostatic force F equals to EE. What we have done it over here, right? So it starts moving towards the positively charged plate, and this force equals to how much? EE. Okay. Then after that, where E is the electronic charge and E is the electric field given by the relation E equals to V by D. As you can see here, this force E, okay, this force is E, and this E equals to how much? V by D, where V is the and then see here, I have written here capital voltage V. Okay, later on we require small v also, and I have given the symbol of the voltage as the V. So here voltage V has been applied, and it is being separated by a distance D, so that the electric field will be set up, and that electric field is V by D. Okay, and then because of that electric field, this electron will experience the electrostatic force, and that force is given by F equals to EE. So I think you got up to here. That's why, what's happening here? That's why I tell you to go through these worksheets, okay, before coming here in the lecture. And then now what we are going to find out, okay? Being the voltage supplied between two plates with a separation of distance D, assume any point Pxy in the trajectory. Okay, now what we are doing is that we are assuming any point. Suppose this is the point. This is the point here that we have assumed. Okay, I think you can see it over here, and let me write it down as P. Okay, so this is the point, and this point is, oh my God, okay, so this point is P. Okay, so this point that I have considered is P. So now we are going to find out the coordinate of this point P. Okay, so what we are going to do here in this worksheet is, now the horizontal displacement x equals to Vt. I have written x equals to Vt. How? Let us see here. So what is my horizontal displacement? Now let us take here. So see here, before than this, so see here, this is the displacement. Yes or no? If it is a displacement, now tell me an expression relating as U, A, and T. Okay, let me write. Tell me a relation relating as U, A, and T. Anyone please unmute yourself and then tell me what's the relation that is relating this relation. Tell me what is that expression that is relating all these four variables S, U, A, and T. One of you please tell me. Unmute yourself and hurry up please. None of you are saying why. What's the relation between displacement, initial velocity, acceleration, and time? Tell me. Tell me, one of you. Yeah, are you there in the class or not? Huh? Let me see. Are they here in the class or not? So only 11 of you are here. Why? Where are the rest of the students? There are around 15, 16 students, right? What happened to them? Go on writing present over here, okay? So that I can see if you are present or not. Now let me ask one of you. So what's the time left now? 5 minutes. Okay, what's the time left? 5 minutes. Okay, so the question is, see here, what's the time left? Or is it over time? No, right? 5 minutes is still left. Okay, the question is here. What is the relation between displacement, initial velocity, acceleration, and time? Please, one of you, please tell me. Who can say? What's the relation between displacement, initial velocity, acceleration, and time? Please tell me. None of you. Has someone written here? Please unmute. Okay, let me ask individually. Okay. Okay, Atithi, is he there? Okay, Atithi, please unmute yourself and tell me the relation between, because you have studied in mechanics, right? The relation between the
Yes,
displacement,
sir.
u, acceleration and time, or initial velocity, acceleration and time. What's the relation, Atithi? S equals to how much?
A- S equals to
Yes, S
UT
equals
plus
to,
1 by 2 AT square.
yeah, very good. Thank you so much. S equals to ut plus 1 by
UT.
2 at square. Okay. So here, this S. Oh, who erased this one? I erased it. When did I erase this one? So see here. So suppose this is being deflected in this way and it's reaching here. Okay. Now we are taking this point here. So it has been changed. The point here and this point, see here, this is the displacement covered, yes or no? And this displacement is divided into two components. Displacement is a vector quantity, yes or no? So see here, this is a vector quantity. If it is a vector quantity, then it will be divided into two components. One is along horizontal, another is along vertical, okay? Similarly here, as this is the displacement from here to here, as this is the displacement, this is divided into two components, and they are horizontal and vertical. Okay, so horizontal component of this is this one, represented by this color of pencil. Okay, so this is the horizontal displacement and this is the vertical displacement. This is the vertical displacement. So if we consider this point P to be xy, so here what I am considering is the point to be P xy, okay, xy, where x is the horizontal displacement and y is the vertical displacement, or horizontal component of the displacement and y is the vertical component of the displacement. Then what we see is, now see here, this pxy can be written in two forms. So here, this pxy can be written in two forms. What are they? Let us see here. One is horizontal displacement, that is x. Another is vertical component of displacement, okay, that is y. So this is x, and this one is y. As you can see it over here, this displacement is divided into two. One is x, another is y, okay. So after this one, now let us see here. So if you are present, go on writing PPP, okay? Because I think I won't be able to get the time. And are you drawing with me or not? Okay, draw along with me, please, everyone. From tomorrow, you have to be there with pen and pencil. Now see here, now this is x and this one is y. Now what we can see here is from this one, see here, okay? I have got another projectile motion. I think you have studied this one in, yeah, you have studied, not I think. You have studied it in, while you studied the projectile motion, yes or no, in grade 11 mechanics. It was a very interesting question. Now see here, if I, please see here, okay, see here, what is the resemblance of this one and this figure? This figure, okay? So see here, this also is just like a projectile. It is projected horizontally. Only here the horizontal velocity is provided here, okay? It is moving, or the initial velocity is only along the horizontal direction here, and there is no any vertical direction. Similarly here, what you find out here is, here also it is projected horizontally only. So see here, we're not making any certain angle. See here, I'm not making 30 degree, 40 degree, but I am making it 0 degree. That means I am projecting it horizontally. So only this much, okay? Then we'll, I think you have to go to the next class. So if I do it, then what you find out, let us find out the velocity component, okay? If we find out the velocity component, then what we see is that there is only a velocity in one direction, that is horizontal direction. So only there will be initial horizontal velocity, there won't be vertical velocity, okay? Now let us finish it, okay? So if there is here also the same thing is happening, instead of going down, it's going up, but it is provided with a horizontal velocity, and it's not here the force due to gravity will be very small because the electron is of negligible size, okay? So force due to gravity is mass of the electron into gravity. As the mass of the electron is very small, please give me time, okay, 2 or 3 minutes. As the mass of the electron is very small, it doesn't, or the force due to gravity doesn't play a huge role here. only one force will be here in this electron, and that is due to this electrical force. And here the upper plate being positively charged, that's why this electron also moves towards the upward direction. So only one force will be there, and that also vertically, just like here. See here is only one force, and that is vertically, but in downward direction, as force due to gravity is higher here. Similarly here also there will be only one force, but not in downward direction, but in upward direction. Okay, only one force in upward direction, and there is no any horizontal force here. Just like here, there won't be any horizontal force here. Similarly here, there won't be any horizontal force. Now let us find out the value of x here. Okay, now let us use this relation s equals to ut plus half h square, that we have used it over here. So this relation we have used here, s equals to ut plus half h square. Now x is the horizontal component, and it has got certain velocity. This has got horizontal velocity, and this one is v, so this is v t. But no any horizontal force is applied here, so acceleration is 0. So vt plus half, acceleration is 0, so half multiplied by 0 is 0, and t square is also 0. So this is the relation. And suppose the t is the time taken for this electron to reach from here to here. Okay, so x equals to vt. Similarly, y equals to, now here, as we have seen here, there is no initial vertical velocity here. There is only initial horizontal velocity. There is no initial vertical velocity here. That's why here v in this expression s equals to ut plus half h square, there is no any vertical component of velocity. So u will be 0. So as u will be 0, it will be 0 plus half h square. So the expression will be half at square. Okay, so up to here we did it. I think you have also drawn along with me. Up to here we did it here. Okay, and then here I have asked why there is no acceleration, because, and there is no initial velocity because. So fill it up to here. Up to here we have finished. Then we shall continue from here in the next class. Okay, thank you everyone. Thank you. Please, you can leave the class because it has been already late. Okay, thank you so much. Let me see how many of you are there. Thank you. There are enough good number of students. Okay, thank you so much. And go through the answer out. Go through the answer out every time. Thank you, Atiti. Thank you.